This is the answer key for the practice midterm exam, which covers lessons 1 through 6 in Math 1111. The questions on the practice midterm exam are formatted and worded just like the questions that you will see on the actual midterm. The practice midterm exam is a graded assignment. It is not optional. You do have 2 attempts and only the highest attempt score is recorded. There's also a midterm exam formula sheet, which is at the beginning of the practice midterm exam and also will be at the beginning of the actual midterm. So I'm going to kind of show that to you and show you what formulas are available. On the midterm exam formula sheet, you have the formula for distance, midpoint, slope, the point-slope formula for writing the equation of a line, the equation for a horizontal and vertical line, the various quadratic forms, quadratic formula, the equation of a circle, the formulas for the difference of 2 squares, difference of 2 cubes, and sum of 2 cubes, and also the equation of a line in slope-intercept form. Please do not waste your time memorizing those formulas. They will be provided on the actual midterm exam. So let's get started. And the first question on the practice exam is to simplify the square root of 117 x to the 7th, y to the 5th. So hopefully you remember that to simplify a radical, you have to ensure that you have no perfect squares under the radical. You have no radical in the denominator of the fraction. You have, I believe you can have no fraction under the radical and so forth. Okay, so just remember that. So I'm going to start by breaking down 117. It's not even, so it doesn't divide by 2, but I believe it will divide by 3. So 117 divided by 3 is 39. And 39 is 3 times 13. So if we break this down and write it out, we have 3 times 3 times 13, and then you have x times itself 7 times, and y times itself 5 times. Because this is a square root, you need pairs of 2. So if I go through and I look at the pairs, I have a pair of 3s. I have 1, 2, 3 pairs of x's, and 2 pairs of y's. If you have a pair, excuse me, it gets released from the radical. So I'm going to release a 3, 3 x's, 2 y's, and I'm left with, whoops, excuse me, got a little equal sign in there that I don't need. And then what's left in the radical is 13xy. In simplified form then, the square root of 117 x to the 7th y to the 5th is 3x cubed y squared times the square root of 13xy. The next question says simplify by rationalizing the denominator and simplifying if necessary. So remember that you cannot have a radical in the denominator of a fraction. And so this problem even tells you how to solve the problem by rationalizing the denominator. So we're going to multiply the numerator and the denominator by the square root of 6. That's the process of rationalizing. Then we're going to multiply, the numerators and multiply the denominators. So I have 3 times the square root of 90 over the square root of 36. And then I need to try to simplify. Square root 36 is 6. I have 3. And I'm going to go off over here to the side and think about 90. 90 is 9 times 10. 9 is 3 times 3. So 90 becomes the square root of 2 times 3 times 3 times 5. Again, I'm looking for a set or a pair of 2. So I have a pair of 3's, which are going to get released. So I have 3 times 3 on the square root of 2 times 5, which is 10, over 6. So I have 9 square root 10 over 6. But then 9 over 6, which is a fraction, can be simplified. 9 divided by 3 is 3. 6 divided by 3 is 2. So in simplified form, we have 3 square root 10 over 2. And guys, you do have to take it that far because the instructions tell you to simplify if necessary. And in this case it was necessary. Next, we're asked to factor 25x squared minus 16y squared. One of the first things that jumps out at me in this particular scenario is that I have 2 terms. And typically when I have 2 terms, I want to consider, do I have the difference of 2 squares, the difference of 2 cubes, or the sum of 2 cubes? I notice this one has a minus sign between it, so I have the options for the difference. And I also notice that my exponents are squared. So this particular problem fits the pattern of a difference of 2 squares, or it could. I can tell that my variables are squared. If I think about it, 25 is a perfect square and 16 is a perfect square. So it does meet the criteria for being the difference of 2 squares. So using the formula to get 25, we would do 5x times 5x. To get 16y squared, we would do 4y and 4y. One is a plus and one is a minus. Now, it doesn't matter whether the first one has the plus sign or the second one, but the 2 terms are going to be 5x plus 4y times the second term, which is 5x minus 4y. The question 4 says to factor the following, and we have 36x squared minus 12x plus 4. It does strike me that I have a common factor of 4, which I could take out, but I also notice I'm just going to do it without taking the 4 out. So if we think about breaking this down, and again, there's various ways for factoring. I'm going to use the box method. Okay, so I'm going to put 36x squared in the upper left and the 4 in the bottom right. 36 times 4, I believe, is 144. It is. And so then I've got to find the pair that will add to 12. So 144, let's see, I could do 1 and 144, 2 and 72, 3 and 48, 4 and 36, 6 and 24. Don't believe 7 will. I don't believe 8 will. Yeah, 8 will. 144 divided by 8. So 8 times 18. 9 times 16. And 12 times 12. Okay, so I need a pair that will add to 12. Huh. Am I missing one? Let's see. I don't think so. All right, it appears that this particular problem, because you can't find a pair, this one cannot be factored. I can't break it down. Even if I were to factor the 4 out, I don't think that would help me. Okay, let's see, just in case, let's double check that. If we factor out the 4, we have 9x squared minus 3x plus 1. Nope. No way to add and get 3. So this particular problem cannot be factored. Question number 5 asks you to multiply and then simplify the rational expression. Typically, when you multiply a rational expression, you're going to multiply the numerators, multiply the denominators. But in this scenario, with the rational expressions, with all the variables in there, it's going to be better to factor everything and simplify it before we perform the multiplication. So my first step is to factor everything. So if I begin on the left on the numerator and I factor x squared plus x minus 6. Okay, so I got x times x. I need a pair that will multiply to 6 and subtract to 1. I believe that's 3 and 2. It's a plus 3 and a minus 2. On the bottom left, or in the denominator on the left, I do have a common factor of 2, and then I have x squared minus 4, which gives me the difference of 2 squares. So I have the factor of 2 and then a difference of 2 squares. I'm going to have x plus 2, x minus 2. On the right, 2x plus 4, I have a common factor of 2, which gives me 2 times x plus 4, and then x plus 7 doesn't factor. When you simplify these particular type problems, we simplify on the bow tie. So if I look diagonally, left to right, I don't have anything in common there. If I look diagonally going up from left to right, I notice that I have a 2 in the numerator and a 2 in the denominator. I have x plus 2 in the denominator as well as the numerator. Then I look on top of each other. On the left, I see I have x minus 2 and x minus 2. On the right, I don't have anything. But when I'm finished, what I have, or what's left, is x plus 3 over x plus 7. And that would be your final answer. All right, number 6 says solve the following inequality. So to solve an inequality, we have to try to isolate the x on one side. It's just like solving an equation with one extra rule or condition, and that rule is if you multiply or divide by a negative number, you have to invert the inequality. So the first thing I'm going to do is add 3 to either side to isolate the x on the left. So I have 2x less than or equal to 4x plus 6. I'm then going to subtract the 4x that's on the right to get it with everything on the left. 2 minus 4x is minus 2x less than or equal to 6. I'm then going to divide both sides by -2. And this is where the special rule comes into play. Because I've divided by -2, I have to invert my symbol, meaning to flip it to the other direction. And 6 divided by -2 is -3. So my solution is x is greater than or equal to -3. But I'm asked to write my solution in interval notation. And to get to interval notation, it may help you to consider what the number line would look like. We would have a solid dot at -3 because it can be used, and we want to be greater, and greater values are to the right. So in interval form, which is the form that you're asked to write the final answer in, we would start at -3. It is included, so it's a square bracket, and it goes on forever to positive infinity. Number 7 asks you to add the following complex numbers and enter your answer in the simplest form, which is a plus bi. Basically, to add complex numbers, we combine like terms. We're going to combine the real part, which is -5, and -11. So we're going to say -5 plus -11 is -16. Same signs, add, keep the sign. Then we combine 7i plus 2i. 7i plus 2i is 9i. So my answer is -16 plus 9i. It is in the simplest form, a plus bi. Number 8 asks us to multiply the complex numbers. Since it is a binomial, 2 terms times 2 terms, we will use a method called FOIL. And we have to remember that I squared is -1. You should never, ever have an I squared in your answer. Okay, so you have to replace it with -1. So I'm going to do this. -4 times -1 is 4. -4 times positive 6i is -24i. 3i times -1 is -3i, and 3i times 6i is positive 18i squared. And then I need to simplify because ultimately I have to have this in simplest form. So the first thing I'm going to do is combine like terms. -24i minus 3i is -27i plus 18. And the second thing I'm going to do is replace I squared with -1. So I have 4 minus 27i minus 18. And finally, I'm going to come back and combine like terms. 4 minus 18 is -14 minus 27i. So -14 minus 27i is your answer in the simplest form. Question 9 says, which of the following is a rational number? Remember, a rational number is any number that can be written as a fraction. It typically is a whole number, a fraction, or a terminating or repeating decimal. So if I look at these numbers, I have 1, which is a whole number, and I can write that as a fraction as 1 over 1. So this number is rational. I see I have a typo. That's supposed to be square root 2. I have 0.7878878887. That is a decimal, but it is not repeating, nor is it terminating. The dots indicate it keeps going, and it doesn't have a repeating pattern. So it is not rational. 0.50500500005. Again, it is not terminating as indicated by the dots, and it is not a repeating pattern. So it is not. Square root of 2, if you try to look at it in a decimal, you get this big long decimal number, which does not repeat and does not terminate, so it is not rational. 10/19 is already in fraction form, and if it's a fraction, it is rational. And they can be positive or negative. It happens to be that all these are positive. Okay. So you have two rational numbers there. You have 1 and 10/19. Simplify the following exponential expression. Your final answer should contain only positive exponents. Okay, so again, this is kind of one of those problems where I'm going to try to simplify first before I do the multiplication, because let's see, if I do the diagonal, I have x squared in the top and x to the fifth in the bottom. So two of them are going to cancel, and I'm left with 3 in the bottom. On the other diagonal, I have y and y to the fourth, so 1 cancels, leaving 3 in the top. I have -4 times -6. So negative times a negative is a positive. 6 times 4 is 24. Y cubed over x to the third. Okay, don't overthink it. Sometimes we get caught up in all the words and all the yucky looking stuff. Okay, but you're just like simplifying a fraction, and we simplify on what we call the bow tie. Number 11 gets into quadratics, and it wants us to solve the quadratic equation. You have several methods for doing that. You can factor, or the second option is to use quadratic formula. It doesn't specify a method. You may choose whichever one you would like. I noticed that this particular one will factor, so I'm going to use the factoring method on this one. So x times x, I need a pair that multiply to 12 and subtract to 4. That's 6 and 2. I want a -4. So the 6 is negative, the 2 is positive. So when I factor it, I get x minus 6 times x plus 2. So one of those pieces had to be 0 initially. So I know that either x minus 6 was 0 or x plus 2 is 0, and I'm going to solve each of those respectively for x. So I'm going to add 6, add 6, so x equals 6. For the other one, I subtract 2 from either side, so x is -2. So the two answers, and I should have 2 because the highest exponent is 2, are 6 and -2. All right, the next question is another one for solving the quadratic. We have 2x squared minus 13x plus 6. To demonstrate it for you, I'm going to do this one by quadratic formula, which is one of the formulas on your sheet. If you don't remember it, it is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A is always the number in front of the squared term. b is in front of the x, and c is the constant. If I'm using quadratic formula, guys, it becomes a straight out substitution problem. So I have x equals the opposite of negative 13 plus or minus the square root of negative 13 squared minus 4 times 2 times 6 all over 2 times 2. So then I'm going to do the math. Okay, you can use a calculator if you need to. I have 13 plus or minus the square root of 169. Negative times a negative is a positive. 4 times 2 is 8, and 8 times 6 is 48. So this is going to be minus 48 over 4. So we have 13 plus or minus the square root of 121 all over 4. 13 plus or minus 11 all over 4. The square root of 121 is a perfect square, is 11. Okay, so then we have 13 minus 11 divided by 4, which gives me 2 over 4, or 1/2. 13 plus 11 over 4 gives me 24 over 4, which is 6. So my final two answers are positive 1/2 and positive 6. Question 13, you're asked to find the midpoint of the line segment with the endpoints -2, 6 and 7, 3. Okay, it's a midpoint. That is one of the formulas that you have. To find the midpoint, you take x1 plus x2 divided by 2, y1 plus y2 over 2. Okay, so the x1, y1, and so forth refer to your ordered pairs. You have two pairs. So the first pair would be x1, y1. The second pair would be x2, y2. And then it becomes a straight out substitution problem. So I have -2 plus 7 all divided by 2, and 6 plus 3 all divided by 2. So I have 5 over 2, or 5/2, and comma 9/2. There it is. And the formula is on the test. What's your addition and subtraction? Use a calculator if you need to. Question 14, you're asked to find the distance between the same 2 points. Okay. The formula for distance, again, is one of the formulas you're given. Distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Again, your x1, y1 correspond to the ordered pairs. You have your first pair, you have your second pair. Okay, so again, it's a substitution problem. So we have the distance equals the square root of 7 minus the -2, which makes it +2 squared, plus 3 minus 6 squared. Again, if you have trouble doing the addition and subtraction, guys, please don't be ashamed to use the calculator. So we have the square root of 9 squared plus negative 3 squared, which is 81 plus 9, which is the square root of 90. And then we need to simplify the radical. You always simplify your radical. It also tells you to do that in the problem. So 90, as we saw earlier, is 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. So we have the square root of 2 times 3 times 3 times 5. We need a set of 2. So we have a set of 3. So it's going to get released. And 2 times 5 is 10. So in simplified form, we have 3 on the square root of 10. All right, number 15 is a multiple choice question on the test, and you're asked to determine which of the following is the graph of the circle. So the first thing I would do in trying to graph the circle is identify my radius. So r squared is 9. If I take the square root of both sides, I find that my radius is positive 3. I also can identify the center because the center of the circle is H and K. Okay, so be careful. Watch these numbers here. Okay, so H is positive 3. My mistake. Should be positive 3. And the K is negative 4. Because the formula, go back to your formula, be careful, make sure it matches up. The formula is x minus h squared plus y minus k squared equals r squared. So the first thing I'm going to look for is to see if my circle is in the right place. So let's see. For this first choice, my center appears to be at 3, positive 4. Wrong location. So that's not it. For the next one, I have my center is at negative 3, 4. Again, wrong location. For the third option, it does appear to be at 3. Oh, that's negative 3, negative 4. So I'm still not in the right place. And the last one, let's see. My center is at 3, negative 4. And I could follow that diagonal line, but it might be easier to count vertically. So if I count vertically from the center, I have 1, 2, 3. So it does appear that my radius is 3. So this one would be the correct answer. Question 16 is to find the x-intercept for the line y equals negative 4x minus 10. To find the y-intercept, or excuse me, the x-intercept for any fraction or for any equation. Okay, to find the x-intercept for any equation, we let y equals 0 and solve for x. It's the x-intercept, so we solve for x, and it's the point where it crosses the x-axis, x, x, x. So if I follow that rule, I'm going to have 0 equals negative 4x minus 10. So I need to solve for x. I'm going to add 10 to either side. So I have 10 equals negative 4x. I'm going to divide both sides by negative 4. So I have x equals 10 fourths or negative 10 fourths, but that simplifies to negative 5 halves. And we're asked to write it as an ordered pair, so we'd have negative 5 halves, comma 0. Question 17 asks us to find the y-intercept. To find the y-intercept for any particular function, we let x equals 0 and we solve for y. The y-intercept is where it crosses the y-axis and we solve for y. So again, this is a straight, flat-out substitution problem. So I have y equals negative 9 fourths times 0 minus 1. Negative 9 fourths times 0 is 0 minus 1, which is negative 1. Writing it as an ordered pair as instructed, we would have 0, comma, negative 1. Question 18 asks you to find the slope through the 2 points. Okay, the slope formula is given on the formula sheet. It is y2 minus y1 over x2 minus x1. Again, you have to realize that your first point is x1, y1. Your second point is x2, y2. And it becomes a straight out substitution problem, and then you do the math. So we have negative 4 minus 3 over negative 10 minus a negative 2. Negative 4 minus 3 is negative 7. Negative 10 minus a minus is plus 2. So we get negative 7 over negative 8, which simplifies to positive 7/8. So the slope would be positive 7/8. 19 says, find the equation of the line that passes through 4, negative 2 and is parallel to y equals negative 5x minus 9. Okay, remember to write the equation of a line. You need to know 2 things. One, you have to know the slope, and you also have to know a point. And we use the point slope form to write the equation, and it is given on your formula sheet. This is the format that I use. So we are given a point to which we can use. So we have the point x1, y1. I need the slope of the line that is parallel to the one given, and if you remember, lines that are parallel have the same slope. So the slope of the given line is the number in front of the x, which is negative 5. So the slope that is parallel is also negative 5. And then it becomes a substitution problem. I have y equals negative 5 times x minus 4 plus negative 2. But I need that to be in slope-intercept form, which ultimately is y equals mx plus b. So I'm going to distribute the negative 5. So I have negative 5x plus 20 plus negative 2 or minus 2. So I have y equals negative 5x plus 18. And there's the equation of the line that is parallel to negative 5x minus 9 and passes through the point for negative 2. Question 20 is a similar question, but it asks me to write the equation of the line that is also again parallel to, I believe this should be, let's do this one as perpendicular. Okay, just so you have an example. Let me make sure. Nope, I got another parallel one. Okay, so parallel. So again, I have my point, which is x1, y1. The slope of the line that I'm given is 8. To be parallel, we have the same slope. So the slope of that one, of the line I'm going to create, is also going to be 8. And we're going to plug into the point slope formula again, which is y equals m times x minus x1 plus y1. So I'm going to put the numbers in. So I have y equals 8 times x minus, the minus 1 makes plus 1, plus 7. And then to put it into the points, or excuse me, slope intercept form, I need to distribute. So I have 8x plus 8 plus 7. So I have y equals 8x plus 15. Then we get to the perpendicular one. Try to get ahead of myself. Find the equation of the line through 8, negative 7, which is perpendicular to y equals 1/2 x minus 9. Okay, remember, to be perpendicular, okay, the slopes are negative reciprocals. So the slope of the line that is given is positive 1/2. The slope of the line that is perpendicular is going to be, you're going to flip it and change the sign. So 2 over 1, make it negative. So you got negative 2. And that's the slope that you want to use in the point slope form. Okay, so y equals m times x minus x1 plus y1. So I have y equals negative 2 times x minus 8 plus negative 7. Again, the final answer should be in slope-intercept form, so I need to distribute. So I have negative 2x plus 16 plus negative 7. So I have y equals negative 2x plus 9. And there is your equation. And finally, number 22 asks you to solve the following system of equations. Again, there's a variety of ways for solving systems. You can do it by graphing, you can use substitution, or you can use the addition-elimination method. When I look at this particular problem, I notice that the equation on the top is already solved for x, which makes me think this is a good problem to use substitution, because I already have that problem solved for x, so that I can take the top equation, which is solved for x, and substitute it into the bottom equation. Just watch your signs and be careful. We have really negative 1 times the x, which is 6y plus 7 plus 7y equal to negative 9. And then I need to distribute the -1. So I have -6y minus 7 plus 7y equals -9. Then I need to combine like terms. So I have -7y, or 6y, excuse me, -6y plus 7y is 1y minus 7 equals -9. I'm ultimately trying to solve for y, so I'm going to add 7, and I'm going to take it over here to the side. Y equals -2. So if y equals -2, I'm going back to the first equation and I'm going to substitute 2 in place of y so that I have x equals 6 times -2 plus 7, which gives me -12 plus 7, which is -5. So written as an ordered pair, x comma y, my solution is -5, -2. So I hope you find this helpful as you prepare to take the midterm exam.